Hello, this is a very quick tutorial. I'd like to talk a little bit on the building BCR and FAR. These two values, floor area ratio, building coverage ratio against the site, and how you can use a massing model with these two values in mind to create a quick conceptual design massing model. So I will start with the BCR and assume you are working on a two-dimension lot. This one is about 150 feet, 675 feet. It's a lot. I want to create a building footprint, but I want to maintain the BCR under certain values. Maybe let's say 30%, 50% of the site, right? What is the process to calculate this? So I will start with some really simple footprint. So imagine this is your building, which is one or multiple rectangular shape. You could carve openings. So for example, this is courtyard situation, or even the courtyard could be a circle. I just make it a little bit extreme. Maybe this circle is even opened up in certain ways. Okay, so assume this is my building footprint. So first thing I want to do is do a command. It's called curve boolean, which will subtract multiple curves and create a patch. So if I select these three curves, enter finish, and then pick a point in the middle, so basically you can generate a patch, or we call it a planar surface, out of these curves. One thing you want to make sure is output. Right now is the curves, but I want to keep the output as a surface. So if you click the swap, you can change the output to surface, and then I can click enter to finish. So basically I generated this planar surface. So the same thing, I can do the curve boolean one more time, and I can pick up these 2 points, and I pick up points in the middle, enter finish, right? So basically what I have now is these two patched surface, right? So I will change this to 3D view. It's easier, you can see they are right here. So the way you can measure the area of these two is very simple. If you just type area, enter, so this will be the total square foot, right? Based on this footprint. So that would be my way to generate the building footprint and calculate BCR, right? So if you figure out the total site area and then you have the building footprint, you can get a BCR very easily. You can also do this with Grasshopper. Maybe I will do that later after I talk more about FAR. Okay, so the concept of FAR is called floor area ratio. Basically, you have to consider the building as a volume. You have multiple levels, 2, 3, 5, and then the FAR is the total floor area, multiple levels, right? So if my building is as simple as I will just extrude the curve surface, right? So if my building, I want to make the solid equals yes, so it has a cap. For the height, let's assume I will have 50 feet, just hypothetical. Enter finish, so you have this massing model, right? So this is a 50 feet high tall building, and this one I will do the same thing, extrude surface, and this time maybe I want to do I don't know, 70 feet, right? So you can have this different height for your building. And then for the total floor area, I will usually, this is my way, I will do a contour to generate floor slab. So I will do contour. This is a command you can cut horizontal lines out of a volume, right? So I do a contour, and I can pick up both volume, right? So this is the two massing model I picked up. Enter finish. Then you can set up a base point that could be along the bottom, and then you can define the vertical as the cutting direction axis. And then for the interval distance between the two, let's say 10 feet, just using a really simple one. So automatically you generate a bunch of curves. So now without deselect, if I just make the selection out, just holding shift, I can drag the curves right out of this original plan. You can see this is a multiple curved lines. And then I can make another selection. I can go to surface. I want to generate the planar curves, right? So basically this will create a new surface based on the enclosed curve. So if I do that, if I move this again, oops, do one more time. Planar curves, right? Just don't deselect, just simply drag it out. Yeah, I keep losing the one of the curve, but that's okay. I think you can easily make selection like this way. You can do edit, selection filter. I want to deselect curves because I only want to care about the surface. So if you make a selection, you have 12 surfaces being selected. So I drag them away. I should also turn on the gimbal. I think gimbal is a pretty neat. If you don't know what I'm talking about, just basic Rhino UI. You can turn on the XYZ axis for manipulation. So now I have, let me reset the filter for selection. So now I have these floor plans, right? At this point, if you type area, what you got is a total construction of the building, right? And then if you divide this value with the site, you have the FAR. Make sense? Yeah, so this is the whole process, how you can generate these two values, BCR, FAR, just by citing the massing model. I do want to say this also could be super useful. For example, your building is not necessarily like a straightforward. So here, all right. So I was trying to do a lattice, but realized that is actually a Maya command. It's not Rhino command. Yeah, Rhino, this is actually called cage, but it's kind of similar. By the way, you can use a lot of Rhino deformation tools like this to reconfigure your massing model. So I will just do a cage edit. This is a pretty common one. So for example, I have this form. Let me just zoom in. And here I will do a cage edit. Right. We'll do cage edit. I can pick the entire model. I think it's global. Oh, hold on a second. Do one more time. Cage edit. Right. Select object. Okay. Select entire object. And then you can deform how you want to deform it. Select control objects. So if I just pick the same thing, I will just using the box or the bounding box. Yeah, I think this is the easy way. So bounding box will be the control points, and then I will do default as a word, and then you can define how many subdivisions you want along the X, Y, and Z. I will just keep everything as 2. Right, so Y as 2 as well, and Z as 2, because I just want to create like a wedged surface. Degrade right now is automatically became 1, so this means it's a straightforward. Enter, and then enter to finish. So what happened is now you have this kind of corner points based on the bounding box. You can pick these points, or you can just click and holding shift I can select both points. Yeah, sometimes it's tricky, you just make sure you're holding shift, select both points, and then if I move the points, you are basically change the I would say the caged boundary of the original model. So this could be pretty handy if your model is not identical along the z-axis. You can manipulate this way. So I can definitely cut the model like this fashion. I can even make one selection, change the footprint, right? So assume you did something like this, enter finish. So I have this kind of new massing model. In this case, I think you have to let me just make a duplication easier. We can see the model, right? So this is a new form like this one, right? And then this one I will go ahead to do the contour. So this will be similar like what we have done before. Pick a point at the base, pick up a z-axis, give 10 feet, right? So you're basically cutting this guy to contours. Once I cut a contour, then I will do exactly the same command, the planar surf, right? So I have this each floor plans, which are different. So this will be enough to calculate area, right? You can type area and calculate total construction square foot. Or if you want to have some more visualization on the massing, you can do extrude surface, right? In this case, I want to make the floor probably 10 feet high, so I just type 10, right? So now I have this new, just make this one a little bit here. So I have this new massing model, which is based on the footprint. Each one is 10 feet high as my total massing. So for this homework, I'd like you to just go ahead, working on this massing model. It could be like multiple buildings. So here maybe I will just do I don't know, symmetry, called a mirror, because the side is relatively long, right? So this is probably my massing model for the whole site. And you should also think about the vertical core, which is the stairs with elevators. At this point, you can keep everything as abstract. I don't worry too much about actual dimension rather than the location there. So I will just do a 15 by 15 feet square. I will make it really high. I will put it here. So this maybe is my vertical core. It's too high. Maybe I will just make it a bit lower. Or I can do, yeah, since you're already in the model, you can do scale 1D. I'm pretty sure you know how to do this. Then I can drag down the height, right? So this is just like a 5-story high tall building. So it's not super tall. And then you can maybe put the vertical core somewhere, which makes sense to you. In North America, so probably we want to create multiple duplications. So if you're holding out, you probably can make duplications. So they are multiple, depends on the building code. They don't have to be identical. I mean, maybe some of them could be in the opposite corner, right, of the building. Yeah, so I will leave this to you. You can decide how many vertical connections. All right, I think this is all for this super quick demo. Just want to show you the whole process. Start with curve bowling, right? Generate basic surface, calculate BCR, then you can extrude this into 3D volume, and then you can do the contour, you can planar curve, you can calculate the total floor area, and then you can calculate FAR. I might do another tutorial just show you how to do this in Grasshopper if many people are interested. I think that's it. Okay, so I will start with the second half of this tutorial. Just talk about using Grasshopper to do the same thing. This is optional, you don't really have to watch. So here I will just simply duplicate. So this is our site, which is a curve, rectangular, and here assume is a building footprint. We want to do the BCR first, right? And after that, we will probably do another version. I will just copy that. I will then do another grasshopper for the FAR. So for this part of the massing model. Okay, so let's start with the first one. So I will run grasshopper. Not sure how much you know. It's a pretty good interface. You can load in geometry and make calculations. All right, so first thing I want to load is this side, right? So side is actually a rectangle, but also you can do a curve. It's the same. So double click, you can pick a curve. Right click, you can set one curve. You can pick the side. So now we got the side in Grasshopper. Then the next thing I want to do is just double click and then type area. I can calculate. So now if I roll over A, you can see the value is 101250, right? So if I actually do the area, so this is the same value. So you know Grasshopper is actually calculating this, right? Then this is the area for the site. Then the next thing I want to do is to divide, right? Because I want to create BCR. When you do the mathematics division, this A area should goes to B, right? Right. So that is the base value. The next one is I want to calculate the square foot of the footprint, right? So which is surface. So type surface, you want to load a BREP as a surface, right click, set surface here. So you got the surface in. So if you don't really do much calculation, if you just repeat the same logic, you can do the area, right? And then I feed the area into A. So basically that is how you calculate the one building footprint with the BCR. So here if I double click, type panel, I can actually preview the values. It's 0.12. So that is the BCR value for this building. However, I have two buildings. So in this case, you want to actually load both surface. So here I will set multiple surface. So pick up both, enter finish. So now you have two values, but here's a problem, right? When you have two values in Grasshopper, they are actually calculated as a list. So the list is a concept in programming. You have multiple items in an array. So you have these two values for the area. You have to add them together, then do the division, right? So to add these two values together in a list, since we don't know how many items in the future will show up in the list, so I will do one more thing, is I want to actually not using addition, I will use mass addition. Right, mass addition means everything will be added together. So here if I fit this guy in, and you have these total values. So that is a 24008. So let me just double check. So type area in Rhino 24008, right? So this is actually accurate. To be safe, you can also sometimes flatten this list, so that guarantee this two value will be smashed. So you got this total value. Then I feed this total value to A. So now you have this BCR as 0.23. So that's basically the logic to calculating BCR with Grasshopper. You might wondering what exactly is the benefit, right? I can do this with a piece of paper. This is all procedurally generated. So that means if I don't know, in the future I have another shape in my site, right? So maybe this is a new footprint. I will move this footprint a little bit here. So if I have a new layout like this, the only thing I need to do is just reload multiple surface as my building footprint, enter finish. then you automatically have this BCR value updated. You don't have to recalculate, so it's pretty cool. And also you can manipulate, the points. Pretty sure you know how to do this. PON, points on. So here, if I move the points here, I basically enlarged the footprint, right? So now you can see the BCR is updating in real time. So it's pretty nice to allow you to real-timely manipulate or see the result. Okay, so I will save the file. Later I can give you this grasshopper file. Let's see, called BCR FAR. Okay. Yeah, so this is definitely, let me just type a panel here. I call this as a BCR based on footprint. Okay, so put this right here. You guys can use. All right, so I will do another code which is a little bit different. Is doing the FAR. So I will using this guy as example. So the logic is exactly the same. I take the footprint I'll take the whole lot, and I take multiple building, right, as my total floor area. In fact, I think the code will be identical, isn't it? Because this is already being stacking with multiple. Yeah, so I think this is actually the same. So I would maybe just say BCR all FAR based calculation. Yeah, that should be the same. So here, for the side, right? So I will reset the curve to here, which is actually identical. For the surface, I will set multiple surface. So in this case, I don't really need the. Let me just make sure I'm selecting the surface, not the massing, right? Oh, this is a massing model. So for the curve is the side. The surface, I will right click, set multiple surface. So if this is your side, I can holding shift, select 4, enter finish. So now you have this FAR value at 0.3. Okay. Oh, I forgot the base, the first floor. So right click, set multiple surface, holding shift, make sure you select all 5, enter. So now you have this 0.49 as my FAR, right? So that's pretty cool. So just to be consistent, if I mirror, right, just pick the objects to mirror. So here is my total floor. I just make it a little bit lower so you can see it, and I will copy this just to be consistent. All right. So now I have this new set of floors, right? They are just the floor slab, and then I can reset multiple surface. Just make sure you pick all the surfaces, right? Have 10. Now you have this FAR value at 0.99. That should be accurate. Okay. All right. Yeah, I think that's pretty much about the whole logic using Grasshopper. You can definitely reconfirm by just using area, right? So here, if I just select this floor slabs and type area, so you have this value, then I will use a piece of paper, write it down, then calculate the square foot of the total site. Then I can manually calculate. I'm pretty sure is the same value. Okay. Yeah, I just thinking this grasshopper would be pretty handy if you don't mind to do a little bit programming. All right. Yeah, by the way, just to confirm our calculation is correct. So the FAR we are trying to achieve is a 1, 1.5, and 2, right? So here you can see this side is almost get 1 FAR value. So if I want to achieve 2, one way is the building could be higher, or could be the footprint will be larger, right? You can have the way to manipulate So I will just make the building a little bit larger. So make a selection, then I will do scale 2D because I don't want to change the height. So here one, here, then I can make a little larger and then move it down, right? So as long as you change these values, then you see this FAR value has been updated. Super cool. If I want to do, hey, I want to do a, I don't know, much closer to 2, I will do scale 1D. Or you can do, point to point manipulation. There's so many things you can do. So I can make this one even longer. So they are not 100% symmetry. So now you can see this value updated to 1.9. So you can actually tweak this until you get the values you like. Another way you can do is just do multiple levels, right? You can multiply this along the z-axis to get more. But overall, I think this is a quick way you can start with a value and then quickly adjust this to meet your expectations.